Alright, Chapter 16, copyrighted off Oxford 2007 University Press. Rail joints and welding rails. Our introduction. A rail joint has always been the integral part of the rail track. It is looked up necessary evil because of the various problems it presents. Early rails were rolled short lengths due to difficulties of rolling and problem with the transportation while increasing temperature. Rails expanded and the expansion needed to be considered at the joints. If it was therefore felt longer than the rail, larger than the required expansion gap, the too limited length of the rail. The rail joint is either an inevitably full feature of the railway track that presents a lot of the problems maintenance of the permanent way. Chapter discusses the various types of rail joints and suitable on railway track. 16.1. Three effects of the rail joint. A rail joint is the weakest link of the track of the joint with the three that breaks the continuity of the rail both in horizontal and vertical planes because of the presence of an expansion gap, imperfection of level of the rail heads. A severed jolt is always experienced with the rail joint where wheels of the vehicle negotiate expansion of the gap. The joint loosens the ballast under the sleeper bed, making the maintenance of the joint difficult. The fitting of the joint may also become loose and causing heavy wear and tear of the track material. Some problems associated with the rail joint are as follows. Maintenance effort. Due to the impact of the moving loads of the joint, the packing under the sleeper loosens geometry of the track, distorted very quickly because of the width of the joint, and requires frequent attention. Generally seems to be about 30% extra labor required for the maintenance of the joint. Lifespan. The life of the rail and sleeper the fastenings gets adversely affected due to the extra stress created by the impacting and moving loads of the rail joint. Rail ends particularly get battered and hugged, and chance of the rail fracture of the joint are considerably high due to the fatigue stresses in the rail ends. Noise effect. A lot of noise pollution is created with the doing the rail joints, making the rail travel uncomfortable. Sabotage chance. Wherever there's a rail joint, there's a potential damage of the removal of the fish plate and rails miscreants and greatly suspectable sabotage. Alright, impact on quality. Impact the quality of the track suffered because of the excessive wear of the track, tear of the track components, rolling stock caused by the rail joints, fuel consumption. Presence of the rail joints results in increased fuel consumption because of the extra efforts required for by the locomotive to haul the train over these joints. 6.2. Requirements for ideal rail joint. Ideal rail joint is one that is provided with the same strength, stiffness for the parent rail. The characteristics of the ideal rail are briefly summarized here. Holding the rail ends. Ideal rail joint should hold both the rail ends in either position location, horizontal as well as vertical planes to provide much for the continuity of the track as possible. This helps avoid wheel jumping over the deviation of the wheel, the normal path of the movement. The strength. The ideal joint should have the same strength and stiffness of the parent rail joints. Expansion gap. The joint should be provided with adequate expansion gap for free expansion contraction of the rails caused by change of the temperature. Flexibility. Ideal rail joint should be provided flexibility for the ease of the replacement of the rails where required. And provisions of the wear. Ideal rail joint should provide the wear of the rail ends, which are likely to occur under normal operation conditions. Elasticity. The ideal joint should provide adequate elasticity as well as resistance to longitudinal force to ensure the trouble-free track. Cost. The initial as well as the maintenance cost for the ideal rail joint shall be minimum. 6.3.1. Type of the rail joints. Nomenclature for the rail joints depend on the position of the sleeper or the joints. 6.3.1. Classification according to the position of the sleeper. The three types of rail joints come under this category. Supported joints and type of this joint. The ends of the rail is supported directly by the sleeper. To expect that the supporting of the joint would be reduced the wear of the tear of the rail. There would be no cantilever action in practice. However, the support tends to slightly raise the height of the rail ends. Such run on the supported joint with normally hard, there is a wear and tear problem in the sleeper supporting the joint maintenance present with quite of the problem. The duplex sleeper is an example of the supported joint. Figure 16.1. Alright, 16.1 shows your supported rail joint on top of the sleeper joint, rail, sleeper. Superintendent joint. This type of joint ends with the railway suspended between the two sleepers. Some portion of the rail is cantilever joint. As a result, the cantilever action packaging under the sleeper of the joint becomes loose, in particular due to the hammering action of moving of the train load. Suspending the joints for the most common type of joints that is with the rail system worldwide, including India. 16.2 shows the sleeper joints, in between the sleeper joints, rail joints, suspended joint. Bridge joints are familiar with the suspended joint, except that the two sleepers on either side of the bridge joint are connected with the beams of a metal flat or a corrugated plate known as the bridge plate. This is type shown, generally not used in Indian railways. 16.3 shows the bridge joint with a metal flat plate. Alright, the metal flat point is between the sleepers and the rails underneath the joint. 16.3b, the bridge joint with a bridge plate. The bridge plate is a convex plate underneath the sleepers with the rail on where the joint goes. 16.3.2 classification based on position of the joint. Two types of joints are fall into this category. Square joint. In this case, the joint of the one rail exactly opposite of the joint and the other rail of the two joint. This is most common with the Indian rails. The joint shows the square joints and the rails. Staggered joints. In this case, the joints on one rail is somewhat staggered and are not opposite direction. Opposite in the joints are the directions. Staggered joints are normally preferred on curved tracks because they hinder central figure forces that push track outward in figure 16.5. This shows staggered joints on a curve. The staggered joints are staggered. 16.4 welding of the rail joint. The purpose of the welding is joint the rail ends together with the application of the heat and eliminate the effect of the evil effect of the rail joint. The four welding methods used on the railways are gas pressure welding, electrical arc, metal arc welding, flash butt welding, thermite welding. The details in this description are methods given below. 16.5 gas pressure welding. This type of welding necessary help to produce the combination of the oxide silicate gas at the rail's ends with the weld brought together, heated and supplied with the burn connection with the oxygen silicate cylinders, meaning with the regulator tubes about 12,000 degrees Celsius, achieved with the temperature to meet the rail ends of the metal sphere, resulting in the fusion welding together with the ends. The rails are to be welded and clamped at the wall by applying pressure at 40 tons of pressure, heated with a temperature about 1,200 to 1,400 degrees Celsius. Butted with an under subset pressure of 20 tons, about 20 tons. The joint is again heated to the temperature 850 degrees Celsius, allowed to cool naturally. It has been seen that the method of welding, the cheapest compared with the flash butt welding, the quality of the welded joints is claimed to be quite good. Both stationary and mobile units available with the gas pressure welding process simple has not been adopted with the large-scale Indian railways. The main reason behind the limited output, the difficult irregularities availability with the gas. India has only one plant that offers gas pressure welding, which is located in Bandel or on Eastern Railways. The progress of this plant is nominal. 16.6 electrical metal arc welding. A method that has generated passing of electrical current across the gap between the two conductors of the metal electrode to coincide with the voltage source and brought close enough to the metal object, thereby producing electrical current between the two objects. A lot of heat generated with electrical arc, causing two rails ends to be fused as a weld. The type of the welding can be done using any of the following methods: insert plate technique, round plate process, enclosed space technique. Indian Railways has recently started welding joints using metal arc process trial basis performance, so they are far been satisfactory. Flash butt welding has been generated with electrical resistance method. The end of the two rails of the welded thermally clamped with the jaws welding machine. One jaw is stationary while the other is movable, and such a gap between the two rail ends that can be adjusted if necessary to prepare the rail ends through a preheated oxide silicate torch. If necessary, the rail ends brought close together. They almost touch each other, and electric current from 35 kiloamps is passed through the interface of the two rails, developing a voltage of 5 volts. The rail is subjected to predetermined number of preheats of 50 to 15 for 52 kilogram rails, or 13 for 90R rails before they are welded. A lot of flash welding, sparking incurs considerable heat generated passing electrical current through between the rail ends. The rail ends automatically move to and fro by the machine temperature, rising the fusion limited by the range of 100 degrees Celsius to 1500 degrees Celsius. At this juncture, the rail ends pressed together with an upset pressure of 37 tons. Final flashing takes place, joining the two rail ends together. The process is so well regulated that any steel that may have been oxidized during the preheating phase gets completely eliminated. The total time taking in the welding joints of 100 and 200 seconds, and loss of rail length is about 20 millimeters from the H of the weld. In this case, the 90R rails, the total welding time is 161 seconds. This includes burn-off period of 20 seconds on preheat time is 65 seconds, or 13 times 5 seconds. Over preheat time is 36 seconds, or 12 times 3 seconds. Final flash is time up to 40 seconds. High quality welded are produced with the flash butt welding method. The cost of the welding joint using the method is quite low compared with the other methods of welding. The method, however, that can be adopted is most economically and efficiently only at the workshop, which capital investments are required in flash butt welding. The standard method of welding rails on Indian rails. Most more railways have One or more flash butt welding plants where they are welded together. The existing plants for the Indian Railways are listed in Table 16.1. 16.1 list of welding plants in Indian Railways. Pre-straightening of the rails. The rails are straightened before the weld in the order to ensure the welded rail, the good alignment. The end of the cleaning ends of the rails are cleaned in the length of 150 to 225 millimeters using electric pneumatic grinders. Adjusting the rail ends if they're brought together with the flash butt welding machine longitudinally, vertically aligned suitability, adjusting the machine. Welding the rails are welded in the flash butt welding machine. Most of the machines for the Indian Railways are manufactured by the AAI welder in Inverness, Scotland. Important characteristics: typical machine manufactured by the AAI welders are presented in Table 16.2. Stripping: as soon as the rail is welded, they're passed through a stripping machine, whereas the extra metal called the upset metal is chipped off. Characteristics of welding machine: maximum clamping force 60 tons, maximum butting force 37 tons, temperature achieved 1500 degrees Celsius. Number of preheats 15 and for 52 kilogram, 13 for 90R. Preheat time 5.5 to 5 seconds. Total time welding 190 seconds, 52 kilogram rail, 161 seconds, 90R rail. Flash stroke 13 millimeters. Butting stroke 10 millimeters. Stripping: in this case, there's no stripping machine is available. The extra material on the rail head is shipped off manually with using pneumatic chisels, which metal is still hot. Spray cooling: after the hot metal is chipped off, the rails are cooled by spray cooling. The profiling: the rails are then correctly profiled. Before straightening the rail, straighten with the post-straightening the rails. The post-straightening the rails, straighten with the post-straightening machine with remove in both horizontal and vertical kinks, and if any of them ensure perfect alignment in both directions. Also, sonic inspection rails as well. The welds expanded to ensure there are no flaws in them. They're particularly important for the second-hand rails examination. Inspection railheads ends are finally examined and inspected with regard to the specified tolerance of the welded surface with a good finish. 16.7.1 output and cost. Average time taken of the welded joint is about 6 minutes for 52 kilogram rail with a 5.5 minutes for 90R rails. About 70 to 90 joints can be welded in an 8-hour shift. Their flash butt welding of the Northern Railway welds are about 160 joints per day with working the double shift. The approximate cost of the railroad about 350 welded include overhead and depreciation charges, etc. 672 Welder Recorder. The quality of the welded it can be accomplished by the welding record recorder, which automatically records the parameters. Continue control of the quality of the weld. The following of the parameters are required for this device: primary amperage of voltage, butting pressure, loss of length. A gradual study of the records of the parameters help with judging the quality of the weld. After that, the desiring action can be taken if any of the parameters is found improperly regulated. A few of these welding records have recently been purchased for the Indian Railways, or being the flash butt welded plants. 1673 automatic flash butt welding machine. Indian have been procured few last superior with Mark IV type of the flash butt welding machines. APA F60. The new design of the machine permits welding rails in sections of 60 kilogram meters above the medium magnesium wear resistant type. The most of the operation in the machine is automatic. Machines are capable of aligning and twisting of the rail and facilitating formation of high quality welded joints. Technical characteristics of the machine given in 6.3. Characters: the APH F60, maximum clamping force 121 tons, maximum forging force 61 tons. Horizontal vertical adjustment 6 millimeters, maximum starting welding gap 190 millimeters, maximum finish welding gap 100 millimeters, maximum force realignment anti-twisting unit 15.5 tons, average unit of the put out with the machine 20 welds an hour. The new automatic flash butt welding has many supplementary machines like grinding machines, pre-hole posting, straightening machines, short blasting, brushing machines that have engine cleaning generators. Cost ensemble of the supplementary machines is about 90 million, whereas the cost of the main welding machines is about 40 million. New welding machines is able to perform most of the operation automatically in time taken within 52 kilogram rail is in approximately 70 seconds. Average output machine is 24 welds per hour. 1674 Manual of the Flash Butt Welding Rails. The code of the practice of flash butt welding rails has been standardized by the Indian Railways from time to time. The latest instruction regarding the contained manual of the flash butt weld and rails 1994 been described the type of suitable of the rails to be welded, the general procedure to be followed, the list of the intolerance of the flash finish joints, as well as the appearance of the test of the joints to undergo to ensure the quality control. Tolerance of flash butt welds. In each completed flash butt weld should be in check for the straightness alignment of the finish for the up to 1 meter and 10 centimeter long straight edge. The permissible tolerance is given in 16.4, but the tolerances can also apply thermite welding, joint bearing welding zones, where the tolerances are specified in plus 10 millimeters, negative 0.0 millimeters. Alright, you got vertical misalignments at 3/10 to 0.0 millimeters center of the one straight edge on your new rails, plus or minus a half a millimeter on center edge of the at 1 meter straight edge. Later misalignment is plus or minus 3/10 of a millimeter at center of the 1 meter straight edge. New rails, plus or minus half a millimeter at the center of the 1 meter straight edge. Old rails, head finishing quarter millimeter of the gauge side with the center of the 10 centimeter straight edge. New rails, 3 millimeter, 3/10 of a millimeter with the gauge side with the center of the 10 centimeter straight edge. Head finishing on top of the table surface, 2/10 of a millimeter of the 0.0 millimeters center of the 10 centimeter straight edge, plus or minus 2 millimeters at the center of the 10 centimeter straight edge. Web zone underside of the head web, top of the base, and both fillets on each side, plus 3/10 millimeters, negative 0.0 millimeters on parent counter. New rails, 3 millimeters, negative 0 millimeters on parent contour. Hard testing joints. A rail joint should be tested for strength and hardness before it is considered acceptable for the railway. The following tests prescribed in Indian Railway. Transverse test. One joint should be tested using transverse test daily before work starts. Flash butt job welding depots, whether to no provisional welding record of depot. When the records have been provided in 103 1000 joints should be tested using the transverse test. In the transverse 1.5 millimeter long test as well with the center of the test taken with placing the cylindrical support with a diameter of 30 to 55 millimeters are placed in 1 millimeter apart. The pressure is applied from the form of the load center of the test piece. It should be shown a minimum record deflection with any of the sign of the cracking. Figure 6.6 shows the transverse test. That shows the half a meter, 1 millimeter span, 3/4 of a millimeter minimum on the load and meeting of the flush butt welded joints on the foot of the rail. The metallurgic test. Macrographic examination flash butt weld is done with every 5,000 weld with a test check for the presence of the posterity of the cracks and slag incursion of the other welding defects. Hardness and test. The hardness test may also be carried with the weld. It affects its own brittleness. Brinell hardness number should be between 210 and 250 becoming that the Brinell hardness number of parent rail is 230. Ultrasonic flaw detection. Every joint, the ultrasonic flaw detection tested using normally 45, 37 degree, 70 degree, 89, 80 degree probes to cover the head of the web of the foot. Fatigue test is done in two strange ranges of 20% reversal plus 27.5 kilograms a meter squared. Millimeters squared by minus 5.5 kilograms meter squared. Range of 33 kilogram meters squared. Plus or minus 25, positive 25 kilogram meters squared to or minus negative 5 kilogram meters squared, range 30 kilograms squared. Welding second-hand rails. Second-hand rails can be welded conveniently with the flash butt welding depots being cropped for the branches of European countries implement the welding second-hand rails on a large scale in order to economize the aspect of the rail. Particular attention of the welding second-hand rails as follows. Check the dimension of old rails per specification. Make of the old rails. Saw the rail ends. Plan the rail head. Permissible wear of the rails to be welded. Permissible marking the gauge side. Ultrasonic inspection of the rails. 6.8 Thermite welding of the rails. There's only the only form of the site welding which is adopted universally. The method first developed with the Goldschmidt with the Germany towards the end of the 19th century. The code of practice welded rail joints, aluminum thermatic process has developed in Indian Railway. The code defined the method of the welding precaution step to be taken before, during, and after the welding of the production of the satisfactory welding joints. 16.8.1 General principle. The principle behind this process: mixture of the finely divided aluminum iron oxide called thermite mixture is ignited with a chemical reaction takes place for the result the evolution of heat production iron and aluminum oxide. If your F2O3 iron plus 2 aluminum equals aluminum oxide trioxide, F2 iron plus heat. This reaction, the 159 grams of iron oxide combines with the 54 grams of aluminum, give the 102 grams of aluminum oxide with a 112 with 112 grams of iron and 182 kilocalories of heat. The reaction isothermic it takes about 15 to 25 seconds to achieve the temperature of about 2450 degrees Celsius, resulting in much molten state with the welded rail ends, which kept the envelope of the molten box. The aluminum oxide is better, being lighter than, however, the float over the top of the bottom forms the slag. 682. Different types of thermite welding. Two types of aluminum thermite welding processes sanctioned from Welding Rail's Indian Rail. The conventional welding of the SKV welding. SKV is the short term of the German phrase Schwitzverhalten mitten Kurzwatzken Vorgmagen, meaning of the short preheat welding method. The technique is referred to as termed as short preheating welding. The rail board is made over the general policy and decide with the of the short preheating welding technique that should be introduced as soon as possible in the rails. Table 16.5 gives the details of the two types of thermite welding. Alright, if you conventional welding with a mode of preheating, side heating the burner with the air patrol with a fuel mixture of using compressor. Preheating time for 45 plus or minus 8 minutes. Green mold, type of the mold. Source of energy achieving the fuel flotation, mainly for the prolonged preheating, partially with the superheated molten thermite steel. Short preheating or SKV method, top heating with the burner with the air patrol fuel mixture using hand-operated compressor. 15 plus or minus 5 minutes preheating time, prefabricated molds, partially with the short preheating, mostly superheated molten thermite steel. 1683. Thermite welding. Thermite welding involves the following operations. Special type of the molding mixtures used to create the mold of the rail with halves of the green molds of the molding mixture, essentially high silica sand mixed with a bentonite sieve to require gradation to the cores of the inner of the permanent ventilation. Sand should neither be too dry nor too wet. Mixed with a dextrin or formal molasses to make the pliable as desired. The molds are clamped to the rail joint in such a way that there is adequate peripheral clearance in rail profile. Normally, green sand molds are used. The conventional thermite welding, prefabricated carbon dioxide and sand molds are used in the short preheating welding. After fixing the lutein molds of the rail ends heated with the blue flame so that you attain the temperature of 950 degrees Celsius or to 100 degrees Celsius for the conventional process, about 600 degrees Celsius for the short preheating process. The case for the conventional welding heating should be continued till the rail ends have turned yellowish red and orange, which can be checked visually with a colored glass. The opening of the provided with the mold through the heating of the supply with the meeting of the burners has the use of any of the following fuels: air and petrol, oxygen, coking gas or liquid petroleum gas, oxygen, propane. The time for preheating is about 30 to 45 minutes for the conventional welding, 10 to 12 minutes for the short preheating welding. Special type of crucible, the line with the magnetite fixed with the near of the rail joint is such a way that which is required can be swung around, brought exactly over the joint. A hole is provided with the bottom of the crucible, which is plugged in closing pin with the asbestos wool sprinkled over the top of the project. In the motion steel, the power slag is strewn over the asbestos wool and is lies undisturbed. Figure 16.7. This shows the thermite mixture with a crucible, seal, and closing pin poured in the mold of the sand, and this is the thermite welding equipment. Our thermite mixture is placed over the inside of the crucible. About 4 to 7 kilograms of the mixture is required for the conventional thermite welding. About 9.0 to 15 kilograms are often used in short preheating welding. Assume preheating is complete with the thermite mixture and ignited using the special igniters made with the barium peroxide aluminum violet. A violent reaction takes place with the crucible, leads to the evolution of heat. The thermite mixture turns the molten bath, and the slag between being lighter than the float top of the molten iron remains at the bottom. Of the reaction takes place with about 15 to 25 seconds. Extra margin of 5 seconds kept with the separation of slag. A temperature of 2,540 degrees Celsius is reached during the process. The crucible is swung around with the closing pin taped up. The molten iron flows down, fills the peripheral area around the molds. The crucible is swung further and slag flows out. Molten thermite steel fuses around the preheated surface of the rail ends and a homogeneous weld made. The molds are removed after about 5 minutes of the demolding. Only the head of the mold, not the foot of the welding, should be exposed. The excess metal is chipped off the top of the rail and the gauge faces with still red hot. 684 post-welding operation. The following operations are carried out after the welding of the rail ends is complete. The rail ends are cooled 3 to 4 minutes. The control and the cooling is required by the alloy steel rail joints. In order to ascertain the rail profile with the finish of the welding rail joint achieved with the use of the hand files and portable grinders, the weld joint is now ready, but the sleepers are shifted to the original position, probably back at least 30 minutes. If it should have the sense of the pouring of the metal before the first train allowed to pass the welding of the joint. The ultrasonic flaw detection testing new methods made by thermite welding should be completed within 30 days of execution of the welds. Thermite process very convenient for warming the weld. There are times the work would need to be carried out with the work site with no extra power required. There is enough to generate during the chemical reaction. The welded joint, however, is found to be weak in the strength compared with the flash butt weld. The conventional process is generally abandoned the Indian railways to pave the way with the short heat process. 1685 short preheat thermite welding technique. Short preheat welding thermite method should be has recently been developed by the Indian Railways medium magnesium where resistant special alloy rails, which are the technique to produce possible to produce total type of the welding and chipping of about 30 minutes. The main feature of the technique is only the 3 to 5 millimeter at each end of the rail is to be welded the heat at the temperature of 6,000 degrees Celsius against heating of the entire cross section of a rail of about 100 degrees Celsius over the length of 10 to 15 millimeters. In the conventional method, thermite welding, large quantity of the heat necessary for the heating of the rail ends supplied with the use of a large quantity of thermite mixture. 1686 conventional welding versus short welding, short preheating welding. A salient feature of the conventional thermite welding in case of 52 kilogram medium magnesium rails versus those of the short preheating welding are listed in table 16.6. You have your welding thermite preheating 7 kilograms, 9.5, and short preheating 10 to 5.5 to 10 through 13 kilograms. Preheating time for petrol air aluminum thermite welding 45 minutes. Preheating thermite welding 10 to 12 minutes. Total time mold with assembly with the final chipping between initial gap between the rail final chipping 60 to 65 minutes. Aluminum thermite, short preheat and thermite 20 to 30 minutes. Initial gap between the rail ends 12 to 14 millimeters. Aluminum thermite. Preheating thermite welding 23 to 25 millimeters. Preheating technique side heating. Aluminum thermic, preheating thermite welding top heating. Type of molds green sand mold. Aluminum thermic, short preheating prefabricated mold. Petroleum consumption 3.4 liters, aluminum thermite welding 1.0 liters, short preheated thermite. Alright, 1687 precautions during thermite welding. In order to ensure the quality of the thermite welding feature joint, the following precautions should be taken. The following prescribed procedure the thermite welding joint should be carried out with strictly as prescribed. Normally, the horizontal vertical alignment to the rail ends will require special attention for the joint. In the particular case, should be taken to the rail end of the joint square with alignment is perfect. Equipment with good order. All relative equipment and gadgets should be in working order available at the site of the important welding equipment with the gadgets. All the rail thermometer, the rail tensor, stopwatch, 10 centimeters straight edge, filler gauge, leather glove, blue goggles, and wire brush with the same slag container, special first aid box or qualified welder. Thermite welding should be done with a qualified welder who holds a valid competency certificate. Effective supervision. Thermite welding should be done only under the supervision of the qualified permanent way inspector, permanent way ministry, which is valid competency of certificate. End of the cropping. Second hand rails should not be welded before the end of the head has been cropped. The rails shall be cropped vertically through the clean kerosene oil and with the help of the brush. Proper gaps. In order to get good result, proper gaps should be ensured for the two rails to be welded. The standard gaps recommended the following: conventional welding 11 meters plus or minus meter. Short preheating welding 24 plus or minus millimeter. 15 millimeter welding 50 plus or minus 2 millimeters. Adequate block. When a conventional method used the thermite welding railing, the running line with the work should be normally not completed in a time block less than 75 minutes. In the case of the short preheating welding, the same work shall be done within a block of less than 50 minutes. Using the rail tensor, a rail tensor must be made with the maintain the correct gap of the thermite welding rails and decreasing range thermite range of temperature. Also with the rail welding along continuous welded rail tracks. In the case of the repairing weld, the 100 meters of each either side of the weld should be stressed in the order to good result. Work to be done on sets. The fields of thermite welding should be done on a set. The variable possible with the ensure quality of the welding joint. Fluting should be done after ensuring the moisture content, the minimum is improve the quality of the weld. In this case, the welding in the rails should be supported about 10 wooden blocks under each of the rail set. Adequate pressure welding should be normally done at 100 to 110 psi. The time taken the preheating should be normally about 10 to 12 minutes. Using wooden planks. The portion of the rail to be welded should be kept on wooden planks to ensure that moisture does not enter the portions. Finished joint after welding joint should be properly finished on both the gauge as well. The non-gauge side extra collar should be removed in the order of the SFD for testing. Joggled fish plate after thermite welding along with welded rail joint should be joggled fish plate with the support of the wooden block as still is cleared by the ultrasonic field failure detection. 1688 Testing of thermite welding. The rail joint should be tested for strength hardness before except for on the use of the railways. This end of the following tests are prescribed in Indian railways. Reaction test. The characteristic of the reaction of thermite mixture was placed in a standard crucible with a scrutinized to ensure the conformance of specified in standard. The aluminum thermite steel is extracted out of the metal. Melted metal is chemical composition determined. Aluminum content should be between 0.3 and 0.7%. The pre-test should be carried out with a mixture of about 250 portions of the thereof. Hardness test. The brittle hardness test is carried out the welding zone. Heating the affected zone parent metal of the rail with the top of the side with the heated head of the test welded about 3,000 kilograms loaded with a 10 millimeter diameter ball for the 10-second average Brendel hardness number for the weld in the heat affected zones as well with the parent metal. Different rail sections should be given in 16.7. If your parent metal welding zone and heated affected zone areas. Transverse braking load test. The test welded position with a cylindrical, semi-cylindrical support with a diameter of 30 to 55 millimeters, distance of 1 meter from the center with a welded plate center of the span loaded in the manner of the foot of the reaction of the foot of the rail tension. The load of the gradually increase of the tile till the rupture of the curve of the weld. The test should withstand the minimum deflection with specified all different sections and type of the rails. One out of every 100-yard welded rails should be picked up randomly and be subjected to both hardness and transverse tests. The 90 ultrasonic testing UTS rails weighing 50 to 60 kilogram minimum braking load with 80 tons will minimum deflection of 15 millimeters at the center tolerance of the various dimensions of the thermite welding as specified with the flash butt welded joints. The important features of flash butt welding and thermite welding are compared in 16.8. Principle of welding. The welding is done at pressure is about 35,000 amps electrical current between the two rail ends. Welding is done initiating thermite welding. Welding is done initiating an exothermic chemical reaction between iron oxide and aluminum. Quality welding, flash butt, excellent. Thermite welding, good. Strength of the weld, good in fatigue. Flash butt, weak in fatigue. Thermite. Time of the required, about 3 to 6 minutes. Flash butt, 10 to 12 minutes. Short preheating, and 30 to 45 minutes conventional. Place for welding, flash butt welding normally done in the workshop. Thermite welding done on site. Cost of welding tolerance, 40 to 600 per welding, 600 per weld. 700 to 1200 per weld. Tolerance very high. Flash butt welding, normal thermite welding. Control of the quality of the weld. Quality can be controlled with the help of the welding record. And flash butt and thermite welding quality control possibly only by working diligently. No more monitoring is possible. Alright, 16.9. Recent development of welding techniques. The methods described above have been further improved with the path of employing the new techniques and equipment. The techniques and equipment that should be described below. Detailed automatic welding recorder, the invention of the welding recorder, the conventional and controlling the quality of the welding, flash butt welding method. The recent development of the recorder is able to not only identify the defects of the flash butt weld, but also indicate the region of the same. The very sophisticated recording system has recently been developed by the German railways to help Siemens. The system gives this visible, audible indication whenever there are parameter control and quality of the welded transgression. Predetermined limits for the recorder help with the considerable exercising proper control of the quality welding. Thermite welding without preheating. The new method of thermite welding rails design involves preheating the current with being tested at the German railways. The necessary heat is produced much larger quantity with a special manufactured aluminum thermite mixture. Method involved with using a special fabricated mold made with pure quartz sand. This method of welding requires considerably less amount of time due to this prior solidification of the material of the mold. A similar method is also being tried in the Indian railways on an experimental basis. Flame cutting welding and torch. A new flame cutting welding torch is under the trial of the Northern Railways. Proposed the technique and then implemented with the desirable gap of the welding track. The prepare weld there is the site conditions. The such warrant time taken in flame cutting was about 2 minutes against 15-20 minutes in the time of the cutting of the hacksaw. Welding gap with a 50mm gap. Welding with a 50mm gap. The technique with the weld joints introduced the 50mm gap has recently standardized in Indian railway. The technique with the gap of the 50mm is created with the cutting of the defect of the joints. The gap is held in position with the help of the tensor. The gap is filled with wider mold heated from the 20 minutes. The welder makes sure it's taken with a larger quantity of the ignited. After the reaction is complete, the same poured into the mold. Demolding is carried out after 5 minutes, and the joint is perfect tolerance is created. Thermite welding joint at about 50 degrees for the height of the collar. Present the experiment then conducted by the Northern Railways to produce the thermite welded production of 50% of the height of the collar. This will help reducing the joggle and the joggle. The fish plate at the bottom of the collar is likely to be designed as the plate rather than curved to facilitate the testing of the ultrasonic rail flaw detection equipment. Alright, your mobile flash welding machine is ordered to produce the good quality welding. The joints Indian rails have been procedure for the K335 mobile flashing welding machine manufactured with a master plaster and thermite Thera shown in figure 16A. 16A shows a mobile flash boat welding equipment. Working cabinet, rear axle, buggy, engine hydraulic equipment, hydraulic drive, 200 alternator for 209 kilovolt amps, chassis, engine hydraulic equipment, work cabinet, welding head filled with a gantry crane. The new machine itself, propelled with a separate electrical generator, can weld with 60 joints per day under the field condition. The approximate cost of the welding comes from about $500 per joint using the machine. Some of the rail joints are used with the rail joints and seared with the weakest link with the track of the flyfish blade with a particular weak with continuous hammering with the joint is resulting in better wear of the rail ends. The rail joints are more suitable as they are satisfy almost all the requirements of ideal rail joint. There are several methods of welding rails. Flash butt thermite welding methods are normally preferred. Flash butt welding is cheaper. Thermite welding also gives better results. Recently developed welding techniques have been made possible to produce high quality welded joints. Questions. Chapter 17. Modern welded railway track.